Hello, Maximus. This is Granny and Grandpa. And we're going to read you a story, solids, liquids, gases, and plasma. This was written by David Adler, and a lady named Anna drew the pictures. Matter is everywhere. Matter is anything that takes up space, even the smallest space, and has some weight, even the smallest weight. A rock is matter. It takes up space and it has weight. Books, shoes, and balls are matter too. A chocolate bar can teach you about matter. If you take a small bite of a chocolate bar, of course it tastes like chocolate. But if you place the bar flat on a table and smash it with your fist, it breaks into tiny pieces. Taste some of those teeny tiny small bits of chocolate. They still taste like chocolate too. Matter is like that. It's made of tiny bits, and each bit has the same properties as the larger ones. Properties are like characteristics. The tiniest bits of matter that have the same properties as the whole are called atoms. And when atoms combine, they make a molecule. So a water molecule is called H2O. That means it has two H's, which are hydrogen atoms, and an oxygen atom. So two H's and an O make water. And I always think that's amazing because hydrogen's a gas and oxygen is a gas, but when they combine, they make a liquid. That's chemistry. So each drop of water is made up of trillions and trillions of water molecules. Each water molecule is made up of even smaller particles, atoms. So an atom is the smallest bit of an element, one of more than 100 known building blocks of our world. Iron, silver, gold, copper, oxygen, hydrogen, and zinc are all examples of elements. Now, what happens when matter changes its form? Well, the molecules that make up ice and other solids are bound together. They don't move. The molecules that make water and other liquids are held together more loosely, so they flow and move about. The molecules that make water vapor and other gases, they're not held together at all. They spread all out. Rocks, pebbles, books, shoes, and balls are solids. A form of matter that has a definite shape. Even a sheet of paper is a solid. Yes, you can fold it, you can cut it into many pieces, but if the sheet of paper is left alone, it will keep its shape. Solids can be hard or soft. A golf ball is a solid, it's hard. A ping pong ball is a solid and it's soft. The golf ball and the ping pong ball might be the same size, but they don't weigh the same. The golf ball is a lot heavier than the ping pong ball because it has greater density. So that means there's more stuff that's packed into it. Water, milk, juice, and other liquids take up space and they have weight. So they are matter too, but liquids don't have a definite shape. They take the shape of the containers, and you can prove this. Fill a glass of water about halfway, So the shape of the water is the shape of the glass. But then pour the water into a square pan. Now the shape of the water is the same as the square pan. Hold on, I missed a page. Liquids are often measured by their volume. That's the amount of space that they take up. Liquids change shape when they are poured from one container to another, but their volume does not change. So if you have two different shapes of measuring cups, you can prove it. Pour enough water into one cup so it reaches the half cup mark, and then pour it into the second one and it will go up to its half cup mark. They may look different, but the volume has not changed. It's the same in the second one as it is in the first one. They just have different shapes. Just like solids, liquids can take up the same amount of space and have the same volume, but not weigh the same. To prove this, you could have two liquids, water and cooking oil. You'll also need two identical paper or plastic cups, a ruler, a marker, and a scale. If you don't have a scale, you can still do the experiment. With the ruler, mark the cups exactly the same height on each one. Now fill one with water and the other one with oil. Now weigh each of them on a scale. The cup with the oil will weigh less, even though it has the same volume. It should feel slightly heavier if it's the water. Water is more dense than oil. Gases are the third form of matter. Gases don't simply take the shape of their containers. They completely fill whatever container or space they are in. Air is a mixture of gases. It fills every corner of every room in your home, but it's difficult to see the air. Smoke is also a mixture of gases, and it's easy to see smoke. Imagine someone put food in an oven and forgot about it. The food would burn, and the smoke would fill up the room. Gases take up space too, but to be a form of matter, it also needs to have weight. Gases do have weight, and you can prove it. Take a large balloon and, again, your scale. Now weigh the balloon. Now blow up the balloon, fill it with air, and weigh it again. The balloon with air will weigh more than it did when it was deflated. Air is a mixture of gases, and air has weight. This says, "Happy birthday, Grandma." Just like with solids and liquids, not all gases weigh the same. You can learn this from balloons. If you hold a balloon filled with air and let it go, without wind, the balloon is just going to fall to the ground. But if the balloon is filled with a special kind of gas called helium, helium is lighter than air. So balloons that are filled with helium, they will float. Gases take up space, and gases have weight. Gases are a form of matter. Do you ever come in the house or come downstairs and smell something really good cooking? That's because the gases from cooking bacon or cookies, they fill up the whole house. So, what did we learn? Matter can change from one form to another, from solid to liquid and liquid to gas. Ice is a solid form of water, and when ice is exposed to heat, it changes from solid to a liquid, it changes to water. And when a pot of water is put on the stove, it boils, and the steam rises above the pot. and then that steam is water vapor, which is a gas. So, when you add heat or take away heat, matter can change from one form to another. And, oops. So look around your room. Since you are looking through air, you are looking through matter. And you are looking at matter because anything you can see is matter. Anything that takes up space has weight, whether it's a solid, a liquid, or a gas. The end.